Okay, so another example. Clues in the title, really. But here we're going to go through another example where the acute angle may not be in the first quadrant. So we're going to figure out why that is. So let's start off first. We're going to expand our expression. So k cos x minus a is equal to k cos x cos alpha plus k cos k sine x sine alpha. The reason I'm saying alpha instead of a is just because I like to differentiate between the two, and this will become a bit clearer in the end. So this is k cos alpha and k sine alpha are equal to what? Right, so cos x, sine x. Awesome. So here cos x is going to be equal to 5. Okay, but sine x here is going to be equal to negative 12. Negative 12. It's really important that you spot that, okay? And anything in the expansion, if this was a negative, that would change. That would change to be a positive, so it would end up being different. So you really need to make sure you get your coefficients right here. It's really important. But what about k here? So k is equal to the square root of 5 squared plus negative 12 squared. Okay, and this is a 5, 12, 13 triangle. So if you didn't have a calculator, you could know that this was 13, but you may well have a calculator. No, you would in this question because the angle's a bit tricky. Okay, so we've got our 13. Okay, this bit often throws people off, okay? So what is the angle? Everyone thinks, okay, well, if I go in here, do I use negative 12 when I'm calculating the angle? Or do I use positive 12, okay? So the answer is, you always just use positive 12, all right? You just use it because this angle here is giving you the size of the angle, not the position of the angle, if that makes sense. What we use the cast diagram to determine the position of this angle, or how much it's been moved by. Let me show what this means. Okay, so stick this in our calculator, we will get 67.4 degrees. Okay, now we need to think about a cast diagram. This is important, it's really important. So CAST. Okay, so I'm going to use the colors again. So for cos, okay, cos here is positive 5. It's going to be positive there and positive there. But sine is a negative, right? So it's not going to be positive there. Okay, it's not going to be positive there. So it's going to have to be positive here and here. Okay, so that means that we're going to be in our fourth quadrant. Okay, so what does this mean when we're figuring things out? Well, you could think, okay, so A is going to be equal to 360 minus alpha, which is going to be equal to 292.6. So our final answer is 13 cos x minus 292.6 degrees. Okay, so that's our final answer. So I'll take us over to Desmos in a sec and hopefully try and make it a bit clearer again why we have to check this quadrant, okay, and why it's so important to relate its coefficients. We're back in Desmos again, and what I've done is I've sketched the graph of 5 cos x minus 12 sine x between 0 and 360 as in the question. Then I've also included this other graph, which is 13 cos x minus k, which is just, we control k down here between the same period, right? And what we're seeing here, that is, if we'd used the 67 degrees we'd calculated from our first from alpha, right? It wouldn't be equal to the graph. So these two graphs here, the blue and the green graph, they aren't equal to each other. Obviously, you can see they're completely different. They're out of phase with each other, right? But when you change this to 292 or 293, as close as we can get, you can see that they perfectly fit over each other. So what using that fourth quadrant does is make sure that the angle that is being used shifts the graph along by the right amount, so it fits in, right? But depending on what expansion you use, this will be slightly different. But for this expansion here, it's really important that you get this correct. Okay, so like saying that again, 67 would just give you the wrong one. So we had to go into the fourth quadrant to get the right angle, so we can absolutely make sure that our expression, so in the question, you could say 5 cos x minus 12x is equal to 13 cos x minus 292. But if it would be minus 67, they're not equal, so you couldn't have said it. So unfortunately, the question would have been wrong. I hope that makes a bit more sense about what we're doing and why we need to use that other angle.